All right. Good afternoon, everyone. This is Sarah Neiswanger, and on behalf of all of us at the National Glass Association, thank you for making time in your day to join us for this NGA Thirsty Thursday webinar. You'll see on your screen we have another session scheduled for June 18th on energy code evolutions. That will be given by our energy code consultant, Tom Culp, and we hope you will register for that soon. In addition, our NGA Glass Conference registration is officially open online on our website, glass.org. Please do venture to the website and take a look at that proposed program as well. Before we begin, let's review the controls for this Teams meeting. On the next slide, you'll see near the bottom of your screen, you should have a control panel that shows icons for the camera, microphone, chat, among others. Please click on the microphone icon to mute yourself while our speaker, Vicente, is presenting. Please also make sure your camera is off by clicking that icon until you see a slash covering it. On the next slide, you'll see we will make time for questions at the end of the presentation. To ask a question, click on the chat feature in Teams. This is the speech bubble icon next to the three dots. Simply type your question into the message box and an NGA staff member will address it. As you've likely seen, you may also join the audio portion of the presentation through your laptop or using the telephone dial-in information on the screen. Should one audio method cause you difficulties, please do exit and try the other method. Now today, I'm pleased to introduce our presenter, Vicente Montes Amoros. Vicente is a facade and structural engineer at Curtain Wall Design and Consulting in their Virginia, Washington, D.C. office, where he's been since 2005. He has designed and engineered different building enclosure systems such as curtain wall, point-supported glass walls, natural stone, precast concrete panels, metal panels, and more. He has also pioneered CDC's solar reflectivity technology. Vicente holds a Master of Science in Facade Engineering from the University of Bath in the United Kingdom and a bachelor degree in Civil Engineering with a major in Structural. He also holds a minor in tall buildings from the Nanyang Technological University in Singapore. Vicente, welcome.
Thank you. Thank you very much for the presentation. Can you hear me?
Yes, we can.
Yes.
Perfect. So thank you to NGA for inviting me to present. Now I'm going to turn my camera off, and although my mother and my wife will disagree, you won't be missing much if I turn it off. So, all right, well, let's get going. Thank you again for taking the time to join me. Overall, I want to tell you what CDC, what we do. Overall, we are a building envelope design, engineering, and consulting firm. We have offices all over the US. We also have offices internationally, and we have been in business for 47 years. For 47 years, this is all that we have ever done, building envelope. Our company started doing this, and we have continued to do this. It's not like we started doing structural engineering and then migrated into doing envelope. No, this is all that we have ever done, and we are a one-stop shop. We can do engineering, consulting, design of building enclosure systems, drafting, investigations, you name it. So the outline for this presentation is we're going to go over the 2018 IBC glass railing system requirements. We are also going to touch on the ASTM E2353 and ASTM E2358 standards, and those are the standard test method for performance of glass railing in permanent railing systems, guards, and balustrades. And the 2358, it's the specification for performance of glazing in permanent railing systems, guards, and balustrades.
I don't know. I mean, today.
I'm getting some feedback. Would you please mind muting your phones? I'm getting some feedback. Could you please mute your phones? Thank you. So the learning outcomes. By the end of this webinar, you will be able to list resources available to determine the IBC requirements for guards, top rails, handrails, and safety glazing. Now, you have to keep in mind that guards and top rails are not the same. By definition, the guards need to resist certain loads and requirements that we will discuss later, and the top rail is simply, for the sake of this argument, a glass edge protector. That's all. Handrails, well, everyone is familiar with that, and safety glazing will also learn about the general requirements. And we're also going to be able, at the end of this presentation, to identify and specify the correct performance and design requirements. So glass railing systems. Well, there's different types of systems, and you have to know that not all systems are created equal. Not all systems meet all requirements in some applications. Here's just a few examples. This one here is a top rail example. This one here is with vertical posts. This one is infill panels. Infill panels have a less stringent requirement per building code. Here's more examples. These examples are for unobstructed views. The one here, I mean, it's an attempt to do something. I don't know what this is, but it looks kind of funny. And this one here on the right has a spigot. And this one here is integrated into the building enclosure. Now, it's important to know that sometimes the glass railing systems are just left there without any specification or without any attention. When projects hire a building envelope consultant, sometimes they oversee this, but this is very important, just as much as any other system. This is a project we did in DC. The one on the left is a project we did, it's Pampier, one of the Pampiers that we did in Boston. The one on the right is U Street, a U Street project in Washington, DC. And the following video I have shown on several of my presentations before. For those who have seen my presentations, you might have seen this video. So here it is again for your enjoyment. And for the ones that haven't seen my presentations before, I think you will like it. Now, you know that things happen when people drink. And this is an example of that. Pay a close attention to the guy in the dark t-shirt. That guy apparently doesn't want to leave the party, and his friends are leaving. So he suddenly decides to exercise, to flex, to do, I don't know what he's doing there, but you'll see what happens. So this guy survived. Natural selection didn't take its course there, but anyways, if this guy hadn't survived, you can rest assured that there was going to be a lawsuit. And in lawsuits, all documents are discoverable, and the different parties were going to be reviewing the documents. And if any requirements happen to be missing or happen to be not there, or the installed system doesn't meet whatever it is, then you are on the hook for it. Of course, the building code is not intended to protect cases or to cover cases like this guy here, Mr. Legend. But if something had happened, then it was gonna get ugly. So here it's the last time for your enjoyment. So moving on, handrails are not guards, and this is a very general statement. There's certain and very specific cases that are covered in the code and the standards that the guards or handrails could be placed or meet different criteria. But in general, for general application, handrails are not guards. Handrails are defined in the building code in chapter 10, section 1014. You'll see these references in parentheses. That's the code section that applies to what I will be discussing here. So in this section, the handrail height is defined between 34 and 38 inches. The guard height is defined at 42 inches. So just there, by that definition, handrails are not guards. So look at this image here. You can see that there's a handrail, but there's no top rail or guard rail. So we'll discuss this later, but please remember this image. In general, the general requirements for glass, and this is for all glass in buildings, safety glass needs to be permanently marked, and it needs to, the label, the glass box, needs to have the manufacturer and the standard with which it complies. Now, another general requirement for all glass in buildings is that if it's not firmly supported on all four sides, you need to have construction documents, shop drawings, analysis and test data that proves and demonstrates that whatever you're installing meets all requirements. Another requirement for safety glazing, safety glazing is required on different locations per the code. One of those locations is glass in railing system applications. And this glass in railing systems is defined as a hazardous location, and hence you need to have safety glazing. On this section in particular, it states that structural glass balusters, infill panels, need to be safety glass, and this is regardless of the area or height above a walking surface. Now, hazardous location requirements say that it needs to meet, the glass in these locations needs to meet the impact test per CPSC 16 CFR Part 1201, and the CPSC is the Consumer Product Safety Commission, and CFR is the Code of Federal Regulations. And please remember that glass is the only material that is regulated by the federal government. There's only one exception though. When your glass is not for doors or is going to be located around a wet surface, then the glass could be tested to ANSI Z97.1. Now, CPSC uses the testing procedures listed on ANSI, and both CPSC and ANSI have two categories for glass. One of the categories is for glass that is less than 9 square feet, and the other one is for more than 9. Glass in railing applications need to meet classification A, Class A. The impact test per ANSI Z97.1 looks something like this. And you have an impactor assembly, and the mass of this impactor needs to be 100 pounds and 4 ounces, very specific. And to meet Class A, your drop height needs to be between 48 and 48.5 inches, also very specific. And the pass-fail criteria is that the 10 largest crack-free particles should weigh no more than the equivalent weight of 10 square inches of the original material. Now, glass in handrails and guards. Per IBC 2018, glass in handrails and guards has to be laminated glass. There's no option. There's an exception, but all glass needs to be laminated, and it needs to be category 2 or Class A. Now, in IBC 2012, having laminated glass was an option. So you have to be careful, and you have to know what building code your building is under, or what you're going to use for the permit. Because 2012 and earlier versions did allow for laminated glass. But now, 2015 and 18, it's a must, except if your monolithic glass, you could have monolithic glass if the glass is not located with a walking surface beneath, or the walking surface beneath is permanently protected from the risk of falling glass. As you can see here on this photo, there's a balcony here with glass at this Miami Performance Arts Center, and it's permanently protected. The walkway underneath is permanently protected with a canopy. So in that case, and if it was 2015 or 18 IBC, you could now the code requirements. Can you still hear me? Because I got a message saying that I was muted.
Yes, we can hear you. Thanks.
Okay, thank you. So the code requirements, the loads that you need, that your railing system needs to meet, and that's 50 pounds per linear foot applied at the top, or 200 pounds applied at the top. Now, for these loads and for design purposes, you have to use a design factor of 4. This is only for design. We've seen people show up to project sites to test compliance of the rail systems, and they start testing to 800 pounds, which is 200 by 4. This safety factor of 4 is only intended for design, not for testing. Very important. Now, a general requirement for glass, and this is in general, all glass in all buildings, vertical exterior glass, needs to resist wind loads when it is exposed to it, and all glass in exterior applications is. And from and it says that it needs to meet the wind loads per components and cladding. We have also seen calculations from companies that use a freestanding wall approach to determine the wind loads on the rails. That is not accurate. That does not meet code. Also, each guard section needs to be supported by a minimum of 3 glass balusters, and the guard needs to remain in place if one baluster panel fails. Now, the top rail, or this guard, is not required if the glass is laminated. So this particular section only applies in the cases where you are allowed to use monolithic glass. And just to remind you, this like a couple of slides ago, monolithic is only allowed where there's no walking surface or the walking surface beneath is permanently protected. Some local codes, however, do require a top rail, a guardrail. So this would not apply. And this is for Chicago. The city of Chicago does require a top rail. Very important, this last one. Very important, because the code requirement says that glass panels shall be tested to remain in place as a barrier following impact or glass breakage. And this needs to be in accordance with ASTM E2353. So after impact, and even if glass breaks, it needs to remain in place. And it needs to remain as a guard. Upcoming code requirements. This is for 2021 IBC. There's no major changes. There's just some language clarifications here and there, but there's no major changes. Now, let's go to ASTM 2353. And this is the standard test method for performance of glazing in permanent railing systems, guards, and balusters. There's 3 tests, different type of tests per this ASTM. One is the static load, shotback impact test, and the pendulum impactor test. Now, there's 4 different classifications per this ASTM. But if you remember the section that we just emphasized, that is very important, that the glass after the impact needs to remain as a guard, that means that per that code requirement, classification 3 and classification 4 would not meet that requirement. So we're looking at classification 1 or 2 to be able to meet the IBC. Now let's move from 2353 to 2358. 53 is the test method, 2358 is the standard specification. The scope of this specification is based on the health and safety of all potential users, and is also intended for normal and anticipated building uses, but not for abuses. This is literally what the specification says. So Mr. Legend here from the video before, that would definitely be not in the scope of this ASTM. Design requirements, you need to have your guard rail at 42 inches from walking surface, and you need to have one if the surface below is 30 inches or more. But for certain applications, and that's public assembly, elementary schools, and multi-family buildings, the top of the guard needs to be at 48 inches if the surface adjacent to it, which would be this case, is more than 20 feet. Now, on 2358, handrails are also covered. The focus of this presentation is not that, so we're just going to go quickly through these requirements. And handrails are required at corridors, ramps, walkways, enclosed stairways, and at ramps that are with a slope of 1 in 20. The height of the rail, it's 34, the minimum, 38 is the maximum. And transfer rails also, it has several different requirements, as well as railing system penetrations, lots of requirements there. And hand grip or graspability, there's some criteria there as well. Now, performance requirements, and this is the deflection performance requirement according to 2358. When the load is applied at the vertical, in this case this post, then the criteria is H/12. For this example, which is 42 inches from walking surface, it would be 3.5 inches. When the horizontal load is applied at the midspan of the rail, this is the criteria, H/24 plus L/96. For this example, it would be 2 1/3/8, the allowable. And finally, when the vertical load is applied at the rail midspan, then this is the criteria. For this example, 5/8. Now, 3.5 inches of displacement at the top, it's a lot. Just imagine leaning on this vertical post and the system itself displacing 3.5 inches. That definitely wouldn't feel safe. And when you have applications like that here on the photo, where you have the shoe mounted to the substrate, and if the shoe is not mounted properly, the shoe itself can rotate. That, in concert with the fact that the glass is very flexible, then you can get to 3.5 in no time. So I think that overall, as an industry, we can do better than the criteria listed here. For ASTM E2358, there's 6 different types of glass railing systems. This is one. Type 1 is supported on all 4 sides, so this would be like an infill panel. Number 2, it's supported on 2 sides. Number 3 is point supported, just on the edges. Number 4 is supported on 3 sides. Type 5 is supported on 1 edge, and you see some of the examples there. And type 6 is supported at the bottom, but point supported. Also, for 2358, there's 4 different levels of performance. Basic is number 1, 2, safety, 3, and 4 are enhanced. Now, pay close attention to the section here highlighted in red. If you see, this is the criteria. These are the loads prescribed in the building code. 200 pounds point load and 50 pounds per linear foot and 50 pounds for the infill panels. That's the level that the building code covers, level 2. If you go to level 3 and level 4, which are enhanced performance, the requirements are higher. You can see here 300 pounds point load and 365 pounds for level 4. Now, per the building code, this is it, as we stated. So when you are specifying, you have to know if you wanna specify. I mean, the building code, it's a given, it's a default. I mean, most of the states in the U.S. have adopted the IBC, so that's a given. But if you want to specify something more, then you have to quote this ASTM. You have to reference this ASTM. And note that system 5, type 5, and type 6, type 6 is here, the point supported, and type 5 is here, which is supported on 1 edge, have higher performance requirements per ASTM 2358. So you have to remember that. Now, ASTM is currently working on there's a task group working on the standard practice guide for design of glass railings and guards and balustrades. So this document is not out yet, but soon enough it will be. And finally, for the end of this presentation, we're going to go through a few images, and we're going to see if it meets code or not. This system here has vertical posts, has horizontal rails, and the glass is behind the horizontal rail. And let's say that is safety glass. So do you think it meets code? Yes or no? So, okay, we have vertical post, okay. We have a horizontal rail, that's at 34 inches from walking surface. The glass behind is behind the horizontal rail, so we probably could consider that glass panel is infill. And the safety glass is not laminated. So, do you think it meets code? Yes or no? The answer is it doesn't meet code. Why? It doesn't meet code because the safety glazing is not laminated. It started with IBC 2006. You had the option to not have a top rail or guard rail if the glass was laminated. In this case, the glass is not laminated and you don't have a top rail. So if one of these panels fails, you don't have anything to protect you at 42 inches from walking surface, which is the height required where you need to have a guard. Next one. You have the glass behind the horizontal rail, you have a handrail, you have a top rail, and you have safety glass. Do you think that it meets code? Infill panel, probably. The handrail is at 34 inches. I'm getting some feedback. Could you please mute your phones? Handrail is at 34 inches. There's a top rail at 42 inches, and the safety glass is not laminated. So do you think that it meets code? Yes or no? The answer is it doesn't meet code. Why? The top rail that you see there is exactly that, a top rail. It's not a guard. That rail that you see on the top is just the edge protector, and it cannot meet the loads prescribed in the building code. It cannot resist 200 pounds per linear concentrated load or 50 pounds per linear foot. It just can't. So if a glass panel fails, that beauty cap is not going to hold you inside the building or this application. So it's not laminated, it doesn't meet code. But now, what if it was laminated? Would it meet code? It wouldn't. Still, it wouldn't. Why? Do you see here this panel at the end? One of the requirements is that each glass baluster needs to be supported, the top rail needs to be supported by 3 glass balustrades. In this case, this one is pretty much independent, this one at the end here. So it doesn't meet code. Next one, we've seen this photo before, glass behind the horizontal rail, handrail, no top rail, safety glass, yes. So perhaps the glass could be considered as an infill panel, perhaps not, depending if you want to say that that glass is your guard. But the glass would need to resist the loads specified. The handrail is at 34 inches, well, fine. You don't need the handrail in this application, only at the stairs, ramps, or etc., as we saw before. And the glass is laminated. So this case in particular does meet code if the glass is laminated. If it's not laminated, you don't meet code because you don't have anything at the top. Finally, this is the last image, the last example. You have this application. It's a glass baluster, handrails, no top rail, safety glass. Glass baluster, fine. Handrails at 34 inches, okay, congratulations, but you don't need it. You don't have a top rail, and the safety glass is laminated. So do you need it, yes or no? I mean, does it meet code? Yes, it does. But something very important. Per the IBC 2018, glass panels need to remain in place as a barrier following impact or glass breakage. So this, what you see in the photo, would need to remain in place. Some design considerations, I mean, you have to know the glass fabrication limits and you have to understand the code. The photos that you see here are an example of someone not understanding the limits. The glass that you see here is bent in two different directions. And for those who fabricate glass, bent glass, know that it can only be tempered if it's bent in one direction. If it's bent in two directions, it cannot be tempered. So the glass that you see here is annealed glass. It was laminated, triple laminated, but it was annealed. So you have to know the limitations. And that is the end of our presentation. I thank you for your time, and let us know if you have any questions.
And Vicente, we've already been getting some in, so why don't we go ahead and get started? The most recent question received regarding uplift force, is there a need to check that as it's a serious safety issue also?
Uplift force?
Uplift force.
So I suppose this would come from someone like picking up the system or so. Wind load, I mean, the system itself won't capture much wind load, so I don't think that would be a concern. But from someone like trying to pick it up, yes, the point load and the linear load, which is 50 pounds per linear foot or 200 pounds, that is supposed to be applied anywhere and in any direction. So in any direction would be like picking it up. So yeah, the requirement is 200 pounds or 50 pounds per linear foot.
Okay. A two-part question regarding differential deflection analysis per IBC 2453.4. First part, is this section generally included in order to avoid a pinch point between two adjacent panels?
That's a good question. Well, so the differential deflection, there's a section in the code. It's on chapter 24. I don't remember exactly. The reference is 2405 perhaps, but this section talks about glazed areas in interior walkways. So if we can classify these systems as an interior walkway, then the differential deflection between each panel has to remain less than the thickness of the glass. That's what the requirement on the code says. Now, how to maintain that to less than the thickness of the glass? You have to design for it. You have to design the glass thickness for it. But if you refer to the commentary of that section in the code, it says very specifically that the reason for that requirement to exist is to prevent pinching of fingers. So if you can do something else to prevent the pinching of fingers, you might be able to qualify for that. But of course, you'll have to consult with the authority having jurisdiction for that case in particular.
Okay. And second part to that question, for the load calculation, you just use the 50 PLF uniform load applied to one panel, not counteracting 50 PLF uniform loads on two adjacent panels. Is that correct?
Well, if we were designing this, we would check both just to make sure that we cover all criteria, that we cover all requirements. And that's including the one that we just mentioned about the pinching of fingers. So if we were designing it, we would check everything, every single case.
Okay. Next question. I've heard that projects can be grandfathered and still use IBC 2012 laminated as an option. Is this correct? It seems after a certain time frame, grandfathered projects are no longer allowed.
That would depend on the local jurisdiction, on the authority having jurisdiction on that particular project. I think that the safest way to do is just to make sure, and this is just my personal opinion, is just to make sure that you know what building code is your building going to be permitted under, and just meet all the requirements for that code.
Okay. Another question. The code indicates design load is to be applied at the top. What if the glass is taller, say 8 feet tall? It seems unnecessary to apply the load at the top. Would you apply the design load at 42 inches?
Yeah, again, this would be depending on the engineer's criteria. If we were doing this and following the requirements for the building code, the code says that you need to have a guard at 42 inches or 48, depending the case, from walking surface, right? So if we were designing this, we would apply the load at 42 inches, and we would also check a different case for applying the load higher. Now, there's some cases where you have like what is being called wind walls, where the glass is 6 feet tall or higher at parapets or amenity decks. For those cases in particular, if you have a piece of cantilever glass going up like 6 feet, cantilevering 6 feet, the design, the governing load is going to be wind load, most likely, and not life load. So you have to check everything.
Okay. Another question, factor safety of 4 is sometimes brought up. When testing the unit, does that mean it needs to be tested at 200 pounds times 4, or is the safety factor 4 already inclusive in the 200 pounds?
No, the safety factor of 4 is not included in the 200 pounds, but the safety factor of 4 is for design purposes. And so when you're designing these type of systems, when you're designing the glass, you have to check with a safety factor of 4, because glass is a very brittle material. And if you're familiar with glass doesn't have like an allowable criteria for strength. It has more of a probability of breakage of X many lights per each 1,000. Sometimes, and depending on the application, is 8 lights per 1,000, 1 light per 1,000, but that's for design. And that's because the glass is very brittle and kind of unpredictable for that. So you pick one of those and you get the modulus of rupture, and that's what you use for the safety factor, the modulus of rupture, not the allowable. But it's not for testing, it's just for design.
Okay. When installing laminated glass in a wet glaze based shoe system, can you discuss materials that may not be compatible with laminated glass?
Well, there's some depending on the product. Some interlayers do not tolerate gypsum-based materials. Some others do not tolerate like cementitious materials or it deteriorates. Some are not compatible. And compatibility could mean that the material itself attacks the interlayer or that it discolors the interlayer, but nevertheless, it's not compatible. From our experience, doing the wet glaze applications like filling the shoe with mortar or gypsum-based materials or something else is not ideal, because if a piece of glass breaks or if you need to replace a piece of glass, then you pretty much have to take everything apart, because once the glass breaks, there's no way that you can clean that shoe to get another piece in. So that presents some challenges. Again, I'm not saying that wet glaze is not okay or that dry glaze is better than wet glaze, but it's something else to consider.
Okay. Where does the current code stand in regard to chemically strengthened laminated glass versus traditional tempered laminated glass? Chemical strengthening offers more ability to bend in unique shapes beyond traditional tempering.
Well, the building code, as of now, only recognizes for this type of applications tempered or heat strengthened, and that's it. I don't know if there's something else out there, if it's being discussed in the upcoming versions, but so far it's just heat strengthened and tempered.
Does all laminated glass and handrail applications need to be tempered laminated?
Well, you will have to check the building code, the version of the building code that you're under, to make sure you're doing the proper thing. Some versions say it could be heat strengthened laminated or tempered laminated.
Okay. Sometimes 3 inches or more is too much deflection for psychological comfort. Do you have a recommendation for a more appropriate deflection criteria than what is in E2358?
Yeah, I agree to that. 3 inches, to me, it's too much. I mean, just imagine leaning on that rail and displacing 3 inches. That's quite a lot. So what we would do, we would do all the checks. Sometimes, as I said before, even for glass rails that are 42 inches tall, sometimes the wind is what controls the design, and sometimes you need more than 5/8 of an inch thick glass to resist the wind loads. So what we would do is we would go through all the checks and we would see what's the maximum deflection. Now, if under life load we get something close to 3 inches, then we would consult with the owner and tell them what the concern is. Although it's fine with the ASTM deflection criteria, we would still bring it up and make sure that they are also comfortable with that.
Okay, we have just 3 questions left. What wind pressure provision would you use on an exterior glass balustrade or on an elevated balcony?
I would use components and cladding from ASE 7, which is also referenced in IBC. And if anything, I guess you could claim that the coefficient of internal pressure, it doesn't apply, but nevertheless, by components and cladding for sure, because that's what the code says. It needs to be all vertical exterior applications with glass need to be components and cladding.
Okay. For wind loading on glass balustrades, do you consider positive and negative pressure simultaneously?
It depends on the case. It depends on how deep the balconies are. If the application is, say, for example, all the way at the top of the building, like a penthouse or like an amenity deck, yeah, wind could apply to both sides. If it's like a balcony, it depends on how deep the balcony is to see if wind on the other side can form. It all depends on the shape of the building and the application.
Okay, and final question. What would you do to protect your firm if a local code enforcer is telling you that half-inch monolithic glass is okay to use in glass rails and balustrades?
Well, I would check the calculations. We had a project recently in DC where half an inch was what was specified. We did the checks with half an inch, and the interlayer was a ionoplast central glass, and then when the interlayer manufacturer got involved, they stated that for analysis, they wanted to have the live load case, the load duration for live load case at 60 seconds. And that made the glass thickness be a little thicker. It wasn't much more thicker, but so, I mean, it depends. You have to look at the calculations and see what the assumptions were. You have to remember that glass interlayers, the combined action between the two plies depends on the modulus, shear modulus of the interlayer. So, and the shear modulus changes with the temperature and with load duration. So you have to check what the assumptions were for that.
Okay, very good. Thank you. That concludes our questions we've received, and I think concludes the education and webinar for today. Vicente, thank you very much for your time and expertise. And we hope to see all of our attendees at this webinar again on Thursday, June 18th for another Thursday webinar on energy codes. Have a great afternoon, and thanks for being here.
Thank you. Thank you very much to all. Thank you to NGA.
Thank you, Vicente.